Okay, guys, welcome to day 15 of integrating for 1,000 days. And today the setup is different again because CBSE cancelled the board exams. So I have officially shifted back to my room, and I no longer live in the dining room. So this is good because I can directly sleep after this, and everything is close by. And this is gonna be the setup for the future videos. So hopefully it's like, what is this? Also, Bozo is hanging there because I couldn't find a place to keep him. So yesterday we started U substitution, and today we're going to continue the concept with a slightly trickier substitution. So today we're going to integrate x by 1 plus x squared, the whole squared dx. Now yesterday we learned that you always take the denominator as our variable. Alright, so here you can see that it's 1 plus x squared, the whole square. Now sometimes here you have to use your brain to figure out what the substitution is going to be. Whether it's going to be the full thing or just the stuff in the bracket. And the best way to do it is to try both of them. If we took 1 plus x squared, the whole square, as our u, we'll assume it. So u is equal to 1 plus x squared, the whole square. You would get du as 2 1 plus x squared into the derivative of 1 plus x squared, which is 2x. And here you can see that you get an x squared term. And we don't have an x squared term in the numerator, so that is not the correct substitution. Oh. So if that's not the correct substitution, we go with our next step. We just take u is equal to 1 plus x squared. And here if we did du by dx differentiate with respect to x, you would get 0 plus 2x. And then if you did a little more transitioning, you would get du is equal to 2x dx. And you can see that the numerator here is x and it's not 2x, and 2 is a constant, so it can be switched to either sides. So you would get du by 2 is equal to x dx, and this x dx you can see is the same thing which is in our numerator. So we got our substitution, and then we have to replace. X dx is equal to du by 2, and constants in integrals you can take outside. So this would just become the integral of 1 by 2, this 2 comes over here, du, and remember our u was 1 plus x squared, whereas in the original term it was 1 plus x squared, the whole square. So here you would have to do u squared. Okay, now you get the integral 1 by 2 du by u squared, so you're integrating with respect to u. So now you can see that it's u squared. And we have a property for 1 by x, which is log x, and we have a property for the power rule, which is just x raised to the power n plus 1 by n plus 1. And here you can see it can't be ln because it's u squared, it's not one term. So here you have to use the power rule. But how do you use the power rule in the denominator? So you would simplify this as 1 by 2, the integration of u raised to minus 2 du, because 1 by u squared is just u raised to the power minus 2. That's the exponential properties. And then here, where's my blue markers? And then here you'd use the power rule again, which is x raised to the power n is equal to x raised to the power n plus 1 by n plus 1. So you get 1 by 2, the 1 by 2 multiplied by u raised to the power minus 2 plus 1 by minus 2 plus 1 plus or minus c, which just becomes u raised to the power minus 1 by minus 2 plus 1 minus 1 by minus 2. And since 1 by u squared was u raised to the power minus 2, u raised to the power minus 1, u raised to the power minus 1 would be 1 by 2u, because the 2 is down and it's a minus, so it becomes a minus. So we get the integral as minus 1 by 2u plus or minus c. But again, there's one thing we're missing here. U is what we created because we assumed it as a variable. So this at the end you would have to simplify and write your answer as 1 by 2 1 plus x squared plus or minus c. So anytime you do u substitution in the final step, you always have to resubstitute u for what you assumed it as, because that's what we're assuming. That's not what the question has given us. So yes, that was the u sub question for today. and it was a little different than yesterday because yesterday we had a 2 here and we didn't have the whole square. So sometimes when it comes like this, you have to figure out what you exactly have to substitute, the full denominator or just the denominator. And it's best to do both and see which one gets you the numerator. So that was the use-up question for today. I'm going to go sleep because I ate too much, and I will see you on day 16. Bye bye.